In this project, we had to determine whether a bag of Skittles or a bag of M&Ms will contain more yellows. We are trying to prove that there is more yellow Skittles than there are yellow M&Ms. After taking data, using confidence intervals, and doing hypotheses tests, you can see that this theory was wrong and they actually contain the same amount of yellows in each bag. The purpose of this project would be to prove that a bag of Skittles has a bigger proportion of yellow Skittles rather than a bag of M&Ms.
The null hypothesis would state that the true proportion of yellow Skittles in a bag is equal to the true proportion of yellow M&Ms in the bag. The alternate hypothesis would state that the true proportion of yellow Skittles is greater than the true proportion of yellow M&Ms. Simple random sample. Sample sizes -10 times 0.2 equals 2. -10 times parentheses 1 minus 0.2 and parentheses equals 8. -10 times 0 equals 0. -10 times parentheses 1 minus 0 and parentheses equals -10. Not all the sample size conditions are met, but we are still going to proceed with the rest of the processes. Population is 10 times the sample. We took a sample size of 10, so 10 times of that would be 100, and there would be at least 100 Skittles or M&Ms in the size of bags that we used to test.
The hypothesis test conditions were simple random sample. Sample sizes were 10 times 0.2 equals 2, 10 times 1 minus 0.2 equals 8, 10 times 0 is 0, 10 times -1 is 0. Even though all the conditions weren't met, we're still going to proceed with the rest of the process. Our population is 10 times the sample, so we took a sample size of 10, and 10 times of that would be 100, and there would at least be 100 Skittles or M&Ms in the size of the bags out. After plugging our numbers into the equations that you can see below, you can see that our confidence interval is -0.0479 to 0.44792. When doing the formulas and mathematics for a hypothesis test, you first need to find the z-score. Our z-score was 1.96. Using this, you'll plug all your numbers into the equation that you see below, and you will get a test statistic of 1.49. After this, you'll make a graph of your z-scores and label your point on there.
I am 95% confident that the true proportion between the number of yellows in a bag of Skittles and a bag of M&Ms would be between -4% and 44%. Since 0 is contained in the confidence interval, it proves that there is no difference between the difference. This means that neither a bag of Skittles or a bag of M&Ms would contain a bigger proportion of yellows in one or the other. I do not have enough evidence to reject the null hypothesis because my test statistic of 1.42 does not fall in the rejection region of 1.96 or above. Therefore, the proportion of yellows that are in a bag of Skittles is equal to the proportion of yellows that are in a bag of M&Ms.